students, welcome back to your physics online class. Students, in the last tutorial we have discussed the last topic. It was parallax method, parallax and parallax method. So I am starting from this topic again. The topic was last topic of the last lecture. You can check the last lecture. This is parallax. Parallax. Let's see first what is parallax, then we will discuss the parallax method also. Actually students, parallax is the apparent shift of an object with respect to another object when we shift our eye sidewise. Repeating, this is the apparent shift of an object with respect to another when we shift our eye sidewise. This is called the parallax. Suppose you have a pencil in front of you or pen in front of you, and you are observing the tip of the pen, and you should have a background wall also. Suppose you have the wall of your room, and you are observing this tip of the pen with your left eye, and suddenly you change the observation of the pen with right eye. Left then right, left then right, left then right. Then you will observe the tip of the pen is shifting. The tip of the pen is shifting opposite to the direction of the eye. It will shift, apparently shift, not actually shifting, because you are holding the pen firmly. Pen is firmly held by your hand, but it appears to shift. Appears to shift means apparent shifting. It is called the apparent shifting. Okay, so this is the parallax. यही है parallax. Again I am repeating, parallax is the apparent shift of an object with respect to another. Means shifting of the tip of the pen, shifting of this pen with respect to back wall. So back wall is the another object, and this is the closer object which is observing by you. So this apparent shifting of the closer object with respect to another means background object, background wall, like in this example. So this is called the parallax, when we change our eye sidewise, left to right, left to right. Okay, so this is the parallax. Now let's see what is parallax method and what is the application. What is the application of this method? So now topic is parallax method. Students, in the last lectures we have discussed the physical quantities. मैंने बताया कि physical quantities are those quantities which can be measured directly or indirectly. Directly or indirectly. Now it is time to discuss the indirect methods. How to measure the distance, how to measure the given physical quantity indirectly. So this is one of the method of observing long distances indirectly. You can say that parallax method is the technique by which we can measure long distances, like distance between the two celestial bodies. You can take the example of distance between Earth and the Moon, distance between Earth and other planets, distance between Earth and stars. So these type of large distances you can't measure by a single instrument. You need some techniques, you need some methods. So this is the one of the method by which you can measure these type of astronomical distances. Okay, so let's see. So first you can write the definition, means what is the parallax method. So you can write parallax method is the method, is the technique by which we can measure the large distances, like astronomical distances, distance between Earth and Moon, Earth and other planets, Earth and stars. Now you can discuss here the measurement of distance between Earth and Moon by this parallax method. I am going to discuss here the method, very interesting method, very important method. very important technique by which you can measure the distance between Earth and the Moon. So let's write. Measurement of distance between Earth and the Moon. Earth and the Moon. By which method? To by this method, parallax method only. Now let's draw the you know that for parallax method we need two things. First, the closer object which is observing, and another means background object with respect to which the closer object is shifting. Okay, two things now. Now see here, suppose this is the Earth surface. This is the Earth surface, and from the Earth we have to measure the distance between Moon and Earth. Suppose this is the closer object, that is Moon. This is the Moon. M, मैंने मार्क कर लिया M. M is the position of the Moon. You know that in parallax method the object is observing by two sides, left and right, है ना? Similarly, now this Moon is observing by two observatories. Two observatories means two positions on the Earth's surface from where the Moon is observing. Actually, we can't use the human eye for observing the Moon in parallax method, because in this example which we have discussed now, just before this topic, the pen tip is observing by left and then right eye. We can use our eye because it is very close to our eye. It is very close to the eye, and it makes the sufficient angle of vision. Angle of vision means this is observing and this is two eye, left and right. So this is the sufficient angle of vision. But suppose this is the Moon and now Earth. So suppose you are observing the Moon with your left and right eye, then it makes very, very negligible angle of vision. So we can't use the human eye for observing the Moon in parallax method. So now see here, we are observing the Moon from these two observatories. Observatories मैंने बता दिया क्या है observatories. Suppose E1 and E2 are observatories, means two position on the Earth's surface. ठीक है? And the Moon is observing. And you know that for observing in parallax method, it requires another object also, background object also. So now for background object, we choose a far positioned star. A far positioned star. A far positioned star. This is S. बहुत दूर है. Far positioned star. Okay. Now, when we observe the Moon with respect to far positioned star S, and the angle between these two positions of star and Moon is θ1. What is the θ1? θ1 is the angle. This is the θ1. θ1 is the angle. Again, this is θ1. θ1 is the angle between the vision of star and the Moon. Okay? And similarly, the moon is observing by the E2 position also with respect to the same far position star. With respect to the same far position star. And the angle between them, this is theta 2. Now, tell me, these two stars are same or different? मैंने बताया same background star, same background far position star. दोनों स्टार सेम हैं, but in this picture, in this figure, these two are separated. दोनों लग रहे हैं they are different, but I am repeating again, both are same star. For example, you are observing the sun from your home, है ना? And at the same time, another person at some distance from your home, he is also observing the same sun. So from both position, the sun will appear at the same place. आपके घर के छत पे से भी सन आपके सर के ऊपर दिखाई दे रहा होगा अगर, और उसी टाइम पे अनदर प्लेस पे कोई पर्सन चेक करेगा तो सन विल ऑल्सो अपीयर एट हिज ओवरहेड पोजीशन. ठीक है, वैसे ही कह रहा है कि अगर ये स्टार बहुत ही दूर पर है तो E1 से चेक करो या E2 से चेक करो, दोनों पोजीशन से चेक करने से स्टार विल अपीयर एट हिज ओवरहेड पोजीशन. जस्ट ऊपर दिखाई देगा उसको. ठीक है, तो आई एम रिपीटिंग, बोथ आर सेम फार पोजीशन स्टार. ये दूर होने की वजह से दोनों पोजीशन से ऑब्जर्व करने से इट विल अपीयर एट द सेम पोजीशन, मीन्स एट his overhead position, सर के ऊपर. Now from the geometry you can prove that this will be theta 1 plus theta 2. From geometry you can prove this theta 1 and theta 1 plus theta 2. Geometry से prove कर सकते हो. You can draw the parallel line from M and you can find the theta 1 plus theta 2 by alternate angles. चलो यहाँ पे ये प्रूफ नहीं करना है हाउ इट मेक्स थीटा 1 थीटा 2. यू कैन राइट हियर जस्ट फॉर फ्रॉम ज्योमेट्री दिस विल बी थीटा 1 प्लस थीटा 2. अब देखो, द डिस्टेंस बिटवीन E1 एंड E2, टू ऑब्जर्वेटरीज यू कैन मेजर, इट इज मेजरेबल, है ना. अर्थ पे दो पोजीशन के बीच की डिस्टेंस इट इज मेजरेबल. सपोज डिस्टेंस बिटवीन दिल्ली एंड कानपुर, you can measure. Distance between Gazipur and Allahabad, Varanasi, you can measure. So suppose this distance is, I am drawing it this sector part separately. It appears like the sector. This is the sector part. Actually earth surface, the part of the surface of the earth appears like straight line, but it is the part of arc. It is the arc also, arc of the sphere or the circle. Now see here, this is M, this is E1, this is E2, and distance between, again I am repeating, E1 and E2 it is measurable. Suppose this is L length, and this angle we have measured theta 1 plus theta 2. Suppose this is theta. Theta 1 plus theta 2 equals to theta. So this is theta. Now you can apply one very popular formula. What? Angle equals to arc upon radius. Angle equals to arc upon radius in this sector. Suppose this is R. For this sector, this is R, both are R. And now check this, what is R? R is the distance between moon and the earth only. ये वही है जो आपको निकालना था. Distance between moon and the earth. So now this angle is theta, which is measured theta 1 plus theta 2. Arc means this is the arc. And radius, this is R, Now from this relation r equals to L upon theta. So from this method you can find the distance between moon and earth. This is r. Okay, so this is the parallax method, from which by the help of this method we can find the distance between moon and the earth. After this topic, let's start one more interesting and very important topic, that is 7 dimensions of the world. Our topic is 7 dimensions of the world. Now see, students, we have categorized the physical quantities in 2 types, especially in 2 types, the fundamental and the derived. मैंने बताया कि derived quantities can be expressed in terms of the fundamental physical quantities. Derived बनती किससे हैं? Fundamental से या basic physical quantities से. And you know that the number of fundamental physical quantities या basic physical quantities are 7. So these 7 symbols of fundamental physical quantities expressed in square bracket are called 7 dimensions of the world. Repeating, the 7 symbols of 7 basic physical quantities expressed in square bracket are called 7 dimensions of the world. Let's write what they are. Dimensions physical quantities कौन सी हैं basic? First is suppose length. For length, the symbol we will use L, and in this square bracket, so this will be one of the 7 dimensions of the world. Second, mass. For mass, we will use M, capital M, in square bracket. Next, for time, we will use capital T in square bracket. Next, temperature. For temperature, we will use the symbol K in square bracket. K here, K is used for Kelvin. It represents the Kelvin. Okay? This is the symbol used for temperature in a square bracket. Next, electric current. Next is electric current. For electric current, we will use the symbol A in a square bracket. A refers here the ampere. Next, luminous intensity. For luminous intensity, we will use the symbol CD in a square bracket. This is small CD in a square bracket. CD means candela. You know that the SI unit of luminous intensity is candela. So this is CD in a square bracket. And now last is amount of substance. Amount of substance. It is mole. Mole in square bracket. So these square brackets symbols are called 7 dimensions of the world. Repeating, these are L, M, T, K, A, C, D, mole in square brackets are called 7 dimensions of the world because these symbols, these dimensions are used to express the other derived physical quantities. Okay? So they are 7 dimensions of the world. Now let's see how these seven fundamental quantities, yeah, 7 dimensions of the world, how they are used to represent a given physical quantity, derived physical quantity. ठीक है? Before starting the expressing the derived physical quantities, we should see here some definitions, like dimensions of a physical quantity. Dimensions of a physical quantity. What is the meaning of dimensions of a physical quantity? So see here, dimensions of a physical quantity are the exponents or power. Are the exponents or power to which the basic quantities must be raised to represent the given physical quantity. ठीक है? जो 7 dimensions of the world हैं, उनके ऊपर क्या एक्सपोनेंट या पावर लगा दिया जाए जिससे कि उनका कॉम्बिनेशन रिप्रेजेंट करे गिवन फिजिकल क्वांटिटी को. तो वो जो एक्सपोनेंट्स या पावर होंगे, दे आर कॉल्ड डायमेंशंस. ठीक है? लेट्स सी विद एग्जांपल. Suppose first I am going to find the dimensional formula या dimensions of velocity. Velocity और speed दोनों के dimensions same होंगे. Velocity और speed both have the same dimension because both have the same units also. ठीक है? And you know that both have the same sense also in case of straight line motion. So we have to find the dimension of speed or velocity. So first thing, keep it in this mind कि for getting the dimension of the given quantity you should know its formula also. Formula पता होगा तभी निकलेगा. So see here, you know that speed equals to distance upon time. This is the formula. Distance upon time. Now we have to find the dimension of speed या velocity. बस velocity में क्या difference होता है? यहाँ पे displacement हो जाती है. But you know that displacement is also basically distance or length. ठीक है? So dimension of speed निकालनी है तो we should know the dimension of this ratio. Dimension of this ratio means dimension of distance upon dimension of time. ठीक है? अब dimension of distance की बात करें तो you know that distance is basically length. Distance है क्या? Basically it is length. इसका मतलब dimension of length. And you know that length is the fundamental quantity. It is represented by L in square bracket divided by नीचे क्या है? Dimension of time. Time is also basic quantity. So in square bracket it is t. Now with the exponent law, you know that when t goes in numerator, it changes it reverses its exponent. यहाँ पे क्या है? एक्सपोनेंट की बात करें तो it is 1. By default it is 1. Here also it is 1. When we shift this t in numerator, then it will change from 1 to -1. So finally we have L and this is t to the power -1. T to the power -1. Then finally we have dimension of speed या velocity क्या हो जाएगी? Combining these two, LT-1. क्या लिख देंगे? LT-1. तो this is the dimensional formula of speed. This is the dimensional formula of speed. And dimensions कोई पूछे? Dimensions of speed तो मैंने बताया डायमेंशंस आर द एक्सपोनेंट्स, है ना। तो यू विल राइट हियर एल के ऊपर बाय डिफॉल्ट क्या है, इट इज 1, तो लिखोगे आंसर लिखोगे 1 इन लेंथ कॉमा -1 in time. These are the dimensions of speed or velocity. Easy है, जैसे कि आपने निकाला हुआ है फॉर्मूला से ही आप निकाल सकोगे डायमेंशंस, ठीक है। तो यू शुड नो द फॉर्मूला फॉर द गिवन फिजिकल क्वांटिटी फर्स्ट. Similarly, write down your homework now. Write down your homework now. Find the dimensions, dimensional formula. Dimensional formula for acceleration, force and momentum. Write down this is your homework. Practice for the dimensional formula of acceleration, force and momentum. ठीक है, so this is all about the dimensions of a given physical quantity. In the next lecture we will see some more dimensions of different physical quantities, and we will see the applications of dimensions also. Dimensions के application बहुत ही important है, they are frequently asking in your examination, ठीक है। So for today's lecture this is sufficient. Thank you for watching this video and God bless you. Keep learning, keep studying. Thank you.